Hello, today we're moving on to our second chapter on food commodities, and we're moving on to cheese. Now, when did cheese come up last? 8 years ago. So therefore it's definitely one of those that are on our radar. To be more specific, cheese was asked on question 2 on section B. Now, this is the only time that we saw cheese as a whole question. Now, I've said to you as well on a number of occasions, home economics, it's all about linking, into different chapters and the ability to do that. So I'm just going to say here, link with calcium, which we know has not been asked since 2019, was also asked in 2015 and 2006. So that's one link because of the obvious reason, milk being a key ingredient of cheese. And then of course I've said to you about osteoporosis, which has not been asked since 2015, which is 10 years ago. So just to keep an eye there on those topics, there's a very obvious link between cheese, calcium and osteoporosis. And another one then would be the fact that this is a protein food. So just going to highlight there that 5 litres of milk to make 500 grams of cheese, and there's twice as much protein in the same amount of cheese as meat. In other words, if I had a 50-gram piece of cheese and a 50-gram piece of meat, there would be twice more protein in my 50 grams of cheese than my meat. So why then are we not saying cheese all the way? Due to the fact that there's quite a high percentage of fat in a lot of cheese, particularly cheeses like cheddar. I'm sure you've all seen, when a pizza comes out of the oven, or a lasagna, or even just something as simple as your cheddar cheese on toast. And when that food comes out from under the grill or out of the hot oven, you often see, this layer of oil floating on the top. And that is where the fat in the food has melted when exposed to the heat and has floated to the surface. So while cheese is a fantastic source of protein, high biological value protein at that, we do need to eat cheese in moderation most of the time because of the fact that it's high in fat. Now, of course, there are cheeses like cottage cheese, which has only got a 4% fat content. And also then we've got cheese that's made from, skimmed milk. Remember, we had that in our first chapter on food commodities, which is fat-free milk. Now, first we need to look at the classification of cheese. Now, I'm sure your head is reeling at this stage. How many more times are we going to see classify or classification? I can't tell you, because all I can say is it's going to be a lot more times. It's one of those words that keeps coming up constantly all of the time. Now, classification of cheese really would only be looked for on a short question. So I'm just going to write here, possible short question. Now, it was asked in the past on a short question, and they accepted hard cheese, semi-soft cheese and soft cheese. Now, what's the difference between each of them? When we go on in our next lesson to how cheese is produced, when the curds, which we'll talk about again, when curds are pressed into shaped molds or containers, they're pressed not just to give shape, but they're pressed into varying degrees. So if the curds are pressed a lot, more moisture or whey is drained out and we get a hard cheese. If the curds are pressed a medium amount, we get a semi-soft cheese. And if we press the curds a very little amount, we get a nice soft cheese. So the more pressure on the curds, the more whey or liquid extracted, and the drier or the harder the cheese. Now, I really would be disappointed if you wrote hard cheese, semi-soft and soft for your classification, because you know you're better than that. For me, that would be a junior cert answer. So you know, I won't go near the ruler on my iPad. It's definitely afraid. I don't say afraid, I'm afraid of it. It does not like me. Here we go with my crooked lines. So as you know, at this point in time, a short question is worth 6 marks. I've said to you already, when you're reading any short question, always have 2 marks for each line there. So we have number 1, number 2, and number 3. So the first one, this is how I would answer classification of cheese if it came up. Firstly, I would say you can classify or group cheese according to the source of milk used. Now remember, each 2 marks could be broken down into 2, 1, 0. So it's not enough for me to write source of milk used. I need to expand on that. So I'm going to say, for example, cow's milk, which would be the most popular. You've all come across goat's cheese made from goat milk, buffalo milk, you know, to make mozzarella. So just to take a couple of examples, and there I'm going to get 1 mark for my source of milk and 1 for my example. Secondly, we can classify according to the type of milk used, which is different from source. Source would be the animal. The type would be, for example, have they used full fat or whole milk to make the cheese, or have they used low fat milk? I'm sure you've seen low fat cheddar cheese or a light cream cheese in the supermarkets. And then the third one, now there's other ways that you can classify other than the 3 I have here. Another one might be the type of mold that you have on cheese. Sometimes the mold is on the outside. Now I'm not talking about the green fluffy stuff that you find on your piece of cheddar that you forgot about, that got hidden at the back of the fridge. Some cheeses, the cheese producer deliberately will inject mold spores into the cheese because it gives a particular texture and flavour. You're familiar with brie and camembert. That rind on the outside of those cheeses, that is mold. Then you have blue veined cheese, like there's a fabulous Cashel Blue, Irish blue cheese. You've got Roquefort, you've got that very famous blue cheese, Stilton cheese, which can only be called Stilton when it comes from that little village, Stilton, in England. So with the brie and the camembert, the mold is on the outside of the cheese, but with the blue veined cheese, the mold is on the inside. So that's another way of classifying cheese. Then you've got farmhouse cheeses, etc. I don't mind which 3 you know, but certainly if you're writing down the classification of cheese, you must mention this one here, and that is the amount of moisture present in the cheese. Why? Because of the fact that it's the most common classification. And I'd even go so far as to put the little asterisks beside it on your answer booklet and just to say most common. Now, students are often afraid with short questions. Can you write below the line? Yes, you can. As long as, remember, you'll see this on your mock paper. See there what I've done in the corner of the page. All of your pages on your official Leaving Cert booklet will have these little marks in the corner, 2 at the top, 2 at the bottom, and whatever information is on the page within those 4 little squares or half squares, the examiner can see. So yes, you can go beyond the lines, or you can do what I'm about to do next. I'm going to break it up into 3 parts. So like I said there, if the curds are pressed a lot, squeezing out lots and lots of whey, you end up with a very dry, hard cheese like a Parmesan or a Gruyere cheese, or another one might be a cheddar. Parmesan, as you know, is so hard, we end up grating it or shaving it with a peeler. Next we have what's called semi-soft. I'd often call that squidgy cheese. Edam, a lovely cheese with a red rind, looks a bit like an apple. That would be a semi-soft cheese. Then of course there's probably the one that we're all familiar with, the squidgy ball of mozzarella, and a really gorgeous French cheese actually. It's called Port Salut. Really lovely on crackers, and it's got a really distinctive bright orange wax with the black stamp on it. And then of course we have soft cheese. Now please do not write down Philadelphia cream cheese, as I've read many times over the years. Philadelphia is a brand name made by a company called Kraft, and obviously they've done very good marketing and advertising over the years. So you just write cream cheese, and that is probably a very famous one or very popular one. Brie would be another one, or Camembert. Now, looking at that, I think that really does deserve 1.5% for Leaving Cert grade. So classification of cheese, possible short question, and that's what I would write. And I would suggest that you write this at the back or at the end of your chapter. So moving back to our next part here, the culinary uses, I'm going to say ordinary level, or you could just read over. They're not going to ask you what do we use cheese for in our diet on an honours paper, but just have a look. Au gratin, love the French. Put a little bit of butter on a few carrots, and they're Vichy carrots, or a little bit of vanilla and sugar into cream, and it's a chantilly creme. And then put a bit of cheese over something, shove it under the grill, and it's au gratin. Either way, you can have cauliflower au gratin, you can have potatoes au gratin, and that is, if it's Italian, then if you're ever in an Italian restaurant, a lot of you probably know this anyway, al forno is the equivalent of au gratin. So al forno in Italian is equivalent to au gratin in French. It's where you've got cheese on top under a grill or an oven, and it comes to the table beautiful golden brown and bubbling. Quiche and lasagna savouries, snacks like a cheese sandwich, dessert like cheesecake, garnishes, French onion soup. As you know, we've got the bread crouton, and you've got the grated Gruyere cheese melted under the grill before it's served. A classic cheese board with soft cheese, hard cheese, and then a cheese sauce. Like I say, just be familiar with it. All we're worried so far is about the classification of cheese and how we'd answer it. Now, lesson 2, we'll be doing the manufacture, packaging and labelling of cheese, which is really important because that was actually asked in 2017. So what we're going to move on to next here is all about rennet. Now, there is no such a food as cheese without what I call this magic ingredient, rennet. Now be careful. I often have students writing down over the last number of years, and they'd say, oh, rennet is an enzyme. Rennet is not an enzyme. Rennet is a substance that is or contains the enzyme renin. So in the past, rennet was got by scraping the lining of a calf's stomach. Now, just to be aware, this is not how we obtain rennet the majority of the time in 2024. So rennet is also known as another word. I've regularly said to you about knowing alternative words. Rennet can also contain renin, which is called chymosin, and that happens to be an enzyme. So rennet is a substance that contains the enzyme, and I'm going to actually say the stomach enzyme, renin. So just to be clear on that. And this rennet is scraped from the lining of a calf's stomach. Now think of this logically. In 2024, do you honestly believe that that type of work, it's so labour intensive, so expensive, is still going on? Yes, it is, to a very, very small degree. Artisan cheese producers, they are using what we call traditional rennet. So just to note that we're talking about traditional rennet when we say it's a substance scraped from the lining of a calf's stomach. So scraped from the lining of a calf's stomach. And when we look at the next lesson, we will see exactly what that enzyme renin is capable of doing, how it can convert liquid milk into curds and whey, and where the curds end up being the cheese. Today we're just looking at the origins or the source of the rennet. So that's traditional rennet and is often used by artisan food producers, because one of the roles of these small little food businesses that produce these artisan foods, a key role is to keep tradition alive. So in order to keep the tradition of cheese making, i.e. how it was done in the past, alive, they need to go back to using what we call this traditional rennet. So used in artisan cheese. Now, if we fast forward to 2024, the majority of rennet in 2024 is obtained. So rennet is obtained by biological, or should we call it biological means, using biotechnology. Now, biotechnology, some of you are probably looking into studying that, the use of microorganisms for various different functions. It could be food production, it could be production of beer, alcohol, it could be looking at microorganisms to break down waste products in a company, etc. Now, there's a place down in Cork and it's called Moore Park, and most of the rennet used in cheese production today in Ireland is coming from Moore Park. Now, I absolutely love this idea. Sadly, I've never come up with any of these genius ideas. So this was a case of the use of what's known as genetic engineering. You may have heard of GM foods, and GM foods are what we call genetically modified foods. Now, as of yet, there is no proper legislation within the European Union for labelling genetically modified foods. And if you ask the students, have you eaten a genetically modified food? No, haven't. Yes, you have. If you have eaten cheese using this rennet that's obtained from Moore Park in Cork. Now, just to talk a little bit about genetic engineering. So, genetic engineering, we'll just take something like a tomato plant, okay? So, just say I produce tomatoes on my fruit, vegetable farm, etc. But I have a problem every year, and the problem is as soon as the frost comes as soon as frost comes, my tomato plants are dead. Yet we have fish out in the middle of the icy Atlantic Ocean, and these fish are capable of surviving the icy cold waters. Why? Because they have a gene that specifically allows them to survive icy cold water. So what could happen here is a genetic engineer is able, it's unbelievable stuff, and there's more and more of this coming down the tracks. So what happens is the gene is isolated, the specific gene that allows fish to survive icy cold water, that gene is isolated, and then the tomato plant is inoculated with the fish gene. So what we've actually done by giving the tomato plant, keeping this simple now, by giving the tomato plant the fish gene, I have modified or altered the genetic makeup of the tomato plant. Next spring comes, the frost comes, or say when the frost comes, the tomato plants don't die because they have been genetically modified. And if I eat those tomatoes, I'm eating GM tomatoes. It's as simple as that. So the most genetically modified plant on planet happens to be soybeans, which, as you know, is very high in high biological value protein, 74%, which is nearly like meat when we come across it 80 to 90%. So link this back to cheese. Rennet is obtained by biotechnology, means in Moore Park in Cork. So what they've done is, by the way, I always have to label my diagram. Nobody, for some bizarre reason, recognises this as a cow. Anyway, here we go. So we know that the cow's stomach, there's a gene in the, so there's the rennet, the lining of the, there's the rennet, the lining of the calf's stomach, and the rennet contains renin, which is the enzyme. I think this is fascinating. So what genetic engineers have actually done is genetic engineers have isolated the gene responsible for producing the stomach enzyme renin. And you know what's coming next? The genetic engineers then have taken this gene, which I want in a different colour, so we'll maybe highlight it here. They've taken this gene and they have inoculated bacteria with the gene. So they have modified the genetic makeup of the bacteria with the cow gene, we'll call it that. And then obviously what's going to happen is the bacteria produce the renin. And in 2024, that's where most of the renin used in cheese production in Ireland is coming from, whereas genetic, or should I say, the traditional rennet is being used by artisan producers. So rennet is a substance which contains the enzyme renin. We note it's a stomach enzyme, and it's obtained by scraping the lining of a calf's stomach. Avonmore used to use that, but certainly artisan food producers or cheese producers, to be specific, still use it also. That's the one I'd go for. Nowadays it's obtained by biotechnology. A strain of bacteria is inoculated with the gene for producing the renin. Moore Park in Cork produces it in this way. Now, vegetarian cheese, it's a non-animal enzyme, which we're going to move towards the end of our chapter here. And just to read a little bit about vegetarian rennet. So it's a non-animal product. So needless to say, if I'm a vegan, I don't want anything to do with cow genes or whatever. I want a totally natural plant source to convert the milk into curds and whey. So instead of animal rennet, which traditionally we said is got from the calf's stomach, what happened, and rennet is also called chymosin. Vegetarian rennet is of two types. So we'll just write down here. So vegetarian rennet can be microbial, or it can be vegetable or plant in origin. And I'm just going to write after microbial there, I'm going to say Moor Park. And we've just gone through that. And then vegetable or plant rennet, thistles of all things, fig leaves, melons would be some examples. So I'll just write down here, wild thistles, safflower, melon, just to name a few. So vegetarian rennet is vegetable or microbial in origin. True vegetarian rennet is produced collecting enzymes, that's really important, from vegetable sources. And we will learn that plants have enzymes as well. My favourite being, any students will know, I love this one, zingibane. It's an enzyme in ginger. You might have covered bromelain, an enzyme in pineapple. Oxidase, an enzyme in fruit. So fig leaves, safflower, melons, and wild thistles. And then microbial, genetically engineered rennet, which Moor Park in Cork, where the gene for making the chymosin or the renin is taken out of a calf's DNA and put into the DNA of yeast, mold, or bacteria. Absolutely fascinating stuff, won't you agree? So that is rennet, the magic ingredient. And rennet can either be traditional rennet, which is got from scraping the lining of a calf's stomach, or it can be vegetarian rennet, which would be from the thistles, etc. Now, just to look at the digestibility. Now, cheese can be easily digested if it's low in fat. Very few cheeses are low in fat, except something like cottage cheese. So the higher the fat content of the cheese, the more indigestible it happens to be. So generally speaking, cheese like cheddar is difficult to digest because of its high lipid content. Raw cheese is more digestible than cooked cheese. We've all seen that cold slice of pizza or cold cheese toasty. Does not look very pleasant, and certainly it wouldn't be easy to digest if eaten. Grated cheese or cheese cut in cubes, easier to digest. So for little kiddies' lunch boxes, cubes of cheese with grapes, I used to call that mouse cheese many years ago, or a grated cheese into a child's sandwich, easier to digest than say a slice of cheddar. And then cottage cheese is easy to digest because we're going to write here it's low fat content, which we said is only 4%. Now, effects of cooking on cheese. We always know 4, which we said on our chapter on milk. So the 4 we're going to go for here: fat melts and separates. Taking, for example, the melted cheese on toast, you see that layer of melted fat on the top. The little loss of food value. Now this is a good one for your revision because there's B2 present in cheese, which is riboflavin. And remember, riboflavin happens to be stable to normal cooking temperatures. Where's B1 gone? I hope in your mind you're saying, well, milk is used or made out of pasteurised milk, and pasteurisation destroys vitamin B1. So there's little loss of food value. Cheese browns on the surface, with the exception of processed cheese. Things like those, what are they, easy singles. Sometimes you'll see people use them, you know, food trucks, etc. They'll have I call it plastic cheese, because it melts really easily, but put that under a grill or into an oven and it'll go jet black. And another one then we'll take is protein coagulates, and the cheese proteins are denatured if overheated or heated for a long time. Next there we have the buying and storing of cheese. So we'll just know 5 here. So we'll pick 5. Store in a fridge, because we know from our study of milk that low temperatures retard microbial growth. Next, wrap cheese in a clean polythene bag and seal. It's going to last longer. Soft cheeses should be used quickly due to their high moisture content. Remember in our chapter on milk, we noted that foods that are high in liquid are like a magnet for bacteria. Buy cheese in small amounts rather than large amounts, you know, and use up quickly. And then brie and camembert are stored at room temperature in France. To be honest, that's because, like, if you look at the first point there, if you want to make a cheese sandwich, this crazy stuff, they say that you should have cheese out of a fridge an hour beforehand to really get the intense flavour. You know, anyone who makes a cheese board, if that's, some families really like a cheese board after a nice meal, the cheese board will always usually be prepared before the meal so that the cheese is coming to room temperature and has a really good flavour. Now that's fine if it's a special occasion or if you're planning your cheese board in advance, but who's going to say, oh, I'd really fancy a sandwich and I'm going to put a bit of cheese, but I need to wait an hour? I don't think so, but that is the ideal. Brie and camembert are meant to be kept at room temperature in like a crock, wrapped in you know, parchment paper. But to be honest, personally, I'd be a bit afraid of that because their soft cheese is high in water, so just to be careful. And processed cheese production, there is no need to learn about the production of processed cheese. I just wanted to mention it because it is, I suppose, one of the popular products on the market. You know, things like cheese strings and Calvita triangles and those easy singles. But why? Why would you eat those? You know, oh, children don't like the taste of, you know, real cheese. You don't have to start them out on a 2-year-old blue cheese or a 12-year-old Parmesan. Start them off on a mild white cheddar, then or a red cheddar, a bit of buffalo mozzarella, etc. But certainly I really don't see the point of these processed cheeses. It's always that they're quite plastic, and that's because when they combine grated mature cheese and immature cheese with the various different ingredients, they heat and they mix at the same time, and that's what gives this very pliable texture to the Calvitas, the easy singles, and so on. Right, that completes today's lesson. So on our next lesson, we'll be looking at a very important part of this chapter, the production, the packaging and labelling of cheese, not since 2017.